we're going to do rational exponents. I want to know what was a rational number. We had the wholes, the integers, and you got to the rational numbers. What were the rationals? What kind of numbers were they? They could be negative.
1, 2, 3, 4, 5.
That would be whole numbers and natural. Any number that can be written as a fraction or a terminating or repeating decimal. But primarily, when you see rational, you should think, oh, they say the word rational, you are doing fractions. A couple chapters down the road, it's an entire chapter of rational functions, which means you're doing fractions with variables in them. So if you see the word rational, you think fraction. Okay, so I want to do exponents, though, that are rational. By the way, this is rule number 6. I'm about to do rule number 6. Okay, so you're going to get a problem that has x to the 2/3. What are you going to do with a 2/3 power? How do you take something times itself 2/3? I mean, because square root means something times itself. Cube root was something times itself 3 times. What's 2/3? It's not. Unfortunately, it's not 2/3 of the number. Okay. It turns out when you have a rational exponent, when you have a fraction, it's really just another way to write a root. You can turn that into a root. The denominator, the 3, is the index on your root.
Really?
Yeah.
But what's
The 2 is the power on inside the root. So x to the 2/3 is really the same thing as the cube root of x squared. You can go back and forth. So if I do this in general rule form, if I give you a to the m over n power, which letter goes out here on the root, the m or the n? The n is on the outside, and you have a to the m power on the inside. So fraction powers is just another way to write a root. They go use. Sometimes it's more, depending on what we're doing, sometimes it's more convenient to have it as an exponent. Sometimes it's more convenient to write it as a root. We use whichever one makes our lives easier. And we just switch back and forth between it.
How would it make it easier than the other one?
Well, depending on what you want to do to it. When you want to, if you want to solve equations with it, or if you want to multiply things together, one form is easier than another form. My calculus students, when they want to do what's called a derivative, we turn it into a fraction. They do the derivative, and then they put it back in a root again. So it makes things better. Okay. So what I'm going to ask you to do, we're just going to see if we can get basics here, is I want to work with numbers, because that's one of the most common places. If I say to you, what's 8 to the 1/3 power, what am I asking you?
What is the cube root of 8?
Yeah, because if it's got a 1 on top, that means the power on the inside is 1. So yeah, that's nothing more than asking you, what's the cube root of 8?
2.
What times itself 3 times makes 8? 2, because that's really just the first power in there. So if I said to you, what is, think of a good number. 625. You might need your pink sheet. To the 1/4 power. So I'm asking you, what's the 4th root of 625? So what number times itself 4 times makes 625? And if you go to your x to the 4th column and look down, you'll see that it's just 5. So now, let's put a little pizzazz in it. Let's combine our exponent rules here. What if I ask you 81 to the negative 1/2 power? What do you do with negative powers? Yes, negative powers means change to the top or bottom of the fraction. So at the moment, are you in the top of a fraction or the bottom of a fraction? Well, since there's no fraction there, you're in the top. So that means just bring it to the bottom. So the 81's down the bottom. What kind of root is a 1/2 power? This is the one you should probably know more than any other. Yeah, if it was a 1/2 power, That means it's a square root of 81. That's you should recognize that anytime you see a 1/2 power, you should think, oh, that's just a square root. No big deal. 1/2s are square roots. So what's my actual answer? 81 is in the square root. So I would actually end up then with just a plain old 1/9. Okay, let me run another one of those by you. What if I said try 32 to the negative 1/5? Nobody say anything. Think to yourself a minute. See if you can do this one without me. Once again, you may want your pink sheet. Is it going to be a whole number or a fraction? It's got a negative power on it. It's a fraction. Okay, so what kind of a root will it be? It's a 5th root. If it'll write. It's a 5th root. So now, think about it. 32 is not a very big number. What's probably the only number that could possibly be times itself 5 times and end up being 32? 2. Yep. So that's nothing more than 1/2. So it really isn't that bad to do. In fact, you're probably going, well, this is easy. Yes, variables are coming, but I'm not through with the numbers yet. Actually, it's the numbers we mess up. The variables are kind of like the exponents. We can find what the exponents on the variables. It's the number bases we mess up. So, let me run through a few more by you. Okay, it gets a little more pizzazzy if the number on top is not a 1. In this case, I have a 3/2 power. If I need to show you the shortcut to working these, there's an easy way and there's a hard way. Okay, well, first of all, put it in a root. What's it going to be? Okay, square root of 25 cubed. Okay, and let me tell you this. Come test time, I'm not going to let you have a calculator on this little part of the test. I'll keep the numbers small, don't worry. Because of the fact that I don't want you to just plug this in a calculator and get an answer. I want you to know how to work it with your brain. Okay, so consequently, if I'm not going to have you give you a calculator, would you want to figure out what 25 cubed is? That would be icky. And that would make you have this great big huge number, and then you got to find the square root of this great big huge number. It's horrible. There's no law that says you have to do the cube root first. You can do the square root first. What's the square root of 25? 5. Square root of 25 is 5. Then you cube that little number to get your final answer. What's 5 cubed? 5 times itself 3 times is 125. So it's always better to do the root first because it makes the number get small, then take it to the power. You never want to do the power first because it'll make you work with much bigger numbers. If I'm asking you to do numbers like this, it's going to work. I'm not going to give you bad numbers. Don't have to sweat that. All right, so let us try what would be fun here. 8 over 125, fraction action with a fraction exponent. What more could you want? They're always possible. So, can you have a fraction in a root? Yep, perfectly legal. Not a problem. Okay. So what kind of a root is it in? The bottom number goes on the outside. And so then I would have my fraction of 8 over 125, but what do I do with that 2? The whole thing is supposed to be squared. Okay. So which would be smarter? Square it first or do the root first? Do the root first. Okay. Ignore the square. Treat them as separate numbers. What's the cube root of 8? Yep, it's 2. Okay, so what's the cube root of 125? What number times itself 3 times? That's 5. Then square your answer. 4 over 25.
Will we be allowed to have a spreadsheet on the test? Yeah. If you
I usually do. Let's put it this way. I've never let them have it before, and they've always been just fine. But I will keep the numbers to 8s and 125s and very common numbers that you know. I won't go off and give you 729 or something that you don't know.
That's probably what you use it for, the big numbers. But you could give us big numbers if you got us out of here.
If it's a really horrible no, hold it. No, I can't even let you have regular calculators. Because they'll still punch this in for you.
How about like really dumb calculators?
Well, yeah, like those little.
Where do you find a really dumb calculator these days? Yeah, that would be a very dumb calculator. Those would be pretty hard to come by. Oh, by the way, I should have made a big issue of this. The instructions to this problem. Any problem like these we just did, the instructions would have been evaluate. Anytime you see in math, a math problem that says evaluate, what is that telling you about your answer? Solve means you got a variable and you're supposed to solve for the unknown variable. What word is inside evaluate?
Value.
Value. What's a value? What is a value in mathematics? A value is a number. If it says evaluate, it means figure out what number does it equal. If it says evaluate, your answer is a number.
So will it say evaluate if there's a variable?
No, it won't say evaluate. If there's a variable, it'll say solve, simplify. Evaluate means, okay, work out what the value of this is. Find the number value. So that's kind of also a tip, even ACT type stuff. If it says evaluate, that should better be something with a number. Okay, so now, yes, we are going to do this with variables too. Yay! Knew you'd be excited. Can I switch colors of my pen? Certainly. What would you like?
Yellow. Yellow.
I heard yellow.
Yellow's noticeable.
The pink doesn't show up good.
Okay, then lime green.
I'll do lime green on the next screen.
Look how well that shows up.
Okay, y'all are going to be excited to see this. Are going to be. Okay. You just had problems on your worksheet for today where you had to multiply two roots together, didn't you?
Yeah.
Okay. But the two roots you had to multiply together on today's assignment had the same index, weren't they? Both square roots or both fourth roots or both whatever roots. Okay? This is a fourth root times a cube root? Can you do that?
No.
Yes. Yes.
Okay. Can you do it in its current form?
No.
No. Can we change it so that we can do it? Yes.
Should we fraction? Yeah, you can change it over.
Okay, the first time here, I'm going to show you how to do it the long way, and then you'll see the shortcut. But you've got to see it this way to know why it works and it's legal. So yes, we're going to change the exponents to fractions. So that would make this become a to the what fraction?
A to 3/4.
That would be 3/4. And this would be b to the, because that's the first power, so it would be a 1/4. This would be a, now in the other root, to the 1/3, and b to the 2/3. Okay, to multiply those together, to take an a times an a, what do you do the exponents?
You add them.
You add them. So I would have to add 3/4 plus 1. Oh, seriously, you're going to moan about adding fractions?
Yes.
You learned it in 5th grade.
They tortured us all these times.
Okay, well, okay, in order to add fractions, what must one have?
The common
Okay,
denominator.
I'm going to tell you the easiest way to do this is go through the whole problem, change them all into the same common denominator. 12. So just go through and just write them all in 12. So that's going to be 9 12s, 3 12s, 4 12s, 8 12s. You just put them all in the same thing. Now, can you multiply them?
Yep.
What will you get?
A.
Actually, hold it. I don't want you to multiply them. I need to show you the shortcut. Yes, you could multiply those, and you would add. You would have 9 12s plus 4 12s, which would be 13 12s. We'll actually write that out here. But we want to put it back in the root. I would get a to the 13 12s and b to the 11 12s. But I want my answer back in a root, and I want you all to see the shortcut. So I'm going to put this back in a root now. Since this is in 12, that would be a to the ninth here, and b to the third. This one would have been a to the 4 and b to the 8th. Take the top numbers off those fractions. Now, I want you to tell me, how could I have gotten from the top line to the bottom line without doing the stuff in the middle?
Like that 12.
The fourth root became a 12. So what did I do to make that 4 become a 12? I times it by 3. So what did I do to every one of these powers? I times them all by 3. And since this was a 3, I had to times it by 4 to make it a 12. So therefore, I times all the ones inside by 4. So you actually don't have to go change it into all the fraction stuff. You just make them have a common index. You look at 3 and 4 and go, oh, I need them both to be 12. And now, multiply them. Whoops, wrong color. What do I get when I multiply a to the 9th and a to the 4th? 9 plus 4 would be, no, we can't freeze right now. And b to the 11th. Notice, how does that answer compare to this one I wrote out here on the right? A to the 13th, b to the 11th, same numbers we got up top there. But let's face it, who wants to have to write all those fractions out? Much easier to just change the roots over and do it. However, am I done? Is that simplified? Is either of these powers bigger than 12? Yeah, the 13 is bigger than 12. So you have to do what? Take out an A. And so, but 12 goes into 13 once with a remainder of 1. It wouldn't go into 11 at all. Okay, as for the even, odd thing, you have to look at the original problem. These both would have had to have been even at the start, and both A's would have had to have been even, or both B's would have had to be even. I would have to work really hard and plan extremely carefully to make a problem work out with an absolute value. It could happen, but I'd have to really try. It's pretty rare that on these kind of problems that you'll have to worry about even, odd. So don't expect to see that. You don't have to write first powers there. I only do that so you can see where I'm getting the numbers, but you don't have to write the little 1 powers. So now you can prove to me you've got it. So suppose I gave you a 6th root of f squared g to the 5th times a square root of f cubed g. I am setting a trap. This is gets people every time. You look at it, you go, oh, 6th root, square root. So what's the root in common? What should I change them both into? Because like here I had a 4 and a 3, so I made them both become 12th roots. So you're saying I would change both of these into. Okay. What index is that? This is a 2, not a 1. I always have people think that's a 1. But still, what's the least common multiple? 6. You can go to 12. You can go to 12, but 6 is actually smaller. Because 6 and 2, they both would be 6 would be common. So yes, you change them both to 6's, which means, do I have to change this first root at all? No. No, it's done. Okay, so you only have to change the second one. How do you change the second one? Because I took the 2 up here on the index times 3 to get 6. So I'm taking every single thing there, every exponent times 3, which that'll make us have f to the 9th and g to the 3rd. Okay, now you can multiply them together. So that'll be f to the what? 2 and plus 9 is 11, and 5 plus 3 is 8. Are you done? Are they simple? Will 6 divide into 11? Yeah. Most of the time you will be able to simplify. So 6 goes into 11 how many times? It goes in one time with a remainder of 5. Okay, 6 goes into 8 once with a remainder of 2. Okay, would I have to sweat even, odd on this one? Were both indexes even to start? Were both F's even? Nope. Were both G's even? Nope. 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 Not for value. Pretty rare if it happens.